Okay, now I'm going to give you some practice. So get yourself a graph plotter and plot this graph here. So you should get something like this. And the question is somehow find a way to draw a tangent line that crosses just crosses 1, 1 here. So I want you to somehow draw the tangent line that just crosses 1, 1, 1. Okay. In order for you to sketch this line here, you would need to know the equation for this straight line here. In order for you to know the equation of the straight line here, you need to know the gradient at this point here. Once you know the gradient, you know it crosses 1, 1, then you can work out the equation of this tangent line. Okay, so somehow draw that tangent line here that crosses 1, 1. So press pause and have a go. Okay, so to do this, look at your original equation here. So looking at the original equation, which is this one here. So now you've got to differentiate it because we want to know the gradient. We want to know the gradient at this point here. Okay, we want to know that gradient. So differentiate it. So when you differentiate it, so looking at this bit here, imagine it as this bubble to the 4 to the power 4 bubble to the power 4. So when you differentiate this with respect to the bubble, you will get 16 bubble to the power 3, and then d bubble by dx, or in which case in this case it's dy by dx. Well, anyway, when you come to differentiate this, it will be 16 y to the power 3 dy by dx here. Okay, so this bit here will be this. Okay, now this one here, well, it's not x is not a function of anything. Well, here when you differentiate it with respect to x, it will just give you 9x squared here, and here you've got to use a product rule here because you've got a combination of x, and in a way x is buried within this thing here. So here you've got to use a product rule. So differentiate this using the product rule. So you got to differentiate the first part, leaving the second part the same. So differentiate the first part, that will give you 6x, leaving the second part the same. Okay, and then the product rule, you got to have a plus, and then keep this the same, which is this, and then differentiate this bubble here, which is 2y, and then you've got to times dy by dx. Okay, and then this part here, again this is a product rule because you've got a bubble here multiplying with another bubble here. Don't forget y is a function of x, so this y has x buried in there somewhere. Okay, so here you've got to use a product rule. So product rule, differentiate this, that will give you 10, leaving this the same here, and then plus, so this is the plus here, plus keeping this the same, and then when you differentiate y, you're just going to get 1, but then you do need to times dy by dx here. That's why you've got 1 times dy by dx. Well, yeah, so if you differentiate this, it will give you this whole thing here. Okay, and then the next step, somehow get dy by dx on its own. So here, now imagine it as you've got one block plus another block here plus another block. Don't forget this here is one block because there's a times in here, and then you've got this block and then this block here. You want to get all the dy's dy by dx on one side. So here remember the equal is here. So get this over to the other side and get this block here over to this side here. Okay, so here this side stays the same. Oh, by the way, tidy this up, that will give you this. Okay, and then in your mind here, you're taking, basically you're moving this across to this side. This one here, it moves across to the other side. This one here moves across to the other side. Basically, you just want to group all the dy's dy by dx on one side here. So now you've got you've got this here. Okay, so note, so you've got one on one side, on the left hand side you've got this, on the right hand side you've got this. Notice that all the dy by dx here, they're all on one side. Now you can factorize all the dy by dx. Okay, so factorize. So factorize. So this here will be this. This here will be this. This here will be this, and so on. And then now you want to get dy by dx on its own, so divide both sides by this bubble here. So basically this is this, and then this here is this. Okay, and then now you've got your dy by dx. So you now have so you can now work out the gradient right at this point. Well, at this point it's going to be 1, 1. So now this is, remember, this is your x, this is your y. So put 1 into x here, put 1 into x here and into here, and then put 1 into the y here, into the y here, and so on. So basically, you now have an equation for working out the gradient at this point here. So put 1, 1 into this thing here, and then it will give you dy by dx here. So yeah, so it will give you dy by dx as this, dy by dx as minus 5 over 12. So now you have a gradient at this point, and you know it crosses 1, 1. So now you've got a line that has a gradient which you know, and it crosses at a point which you know. So you should be able to work out the equation of a straight line. So remember, an equation of a straight line is y equals mx plus c. You know the gradient. The gradient is this here. And you know it crosses at 1, and you know it crosses at 1 here. So now it's just a matter of working out c. So it's blah 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 here, and then c equals 17 over 12. So now you've got your equation of a straight line here. Okay, so now tidy this up, it would become this. So the equation of a straight line, of that straight line, is this here. So when you get if you get your graph plotter and plot y equals 17 minus 5x over 12, it will look like this. You can see that it crosses 1, 1, and it just touches. Well, it is a tangent. You can see it's a tangent. The interesting point is that you looking at this here. Hang on. Looking at this here, you've got an equation for working out the gradient at any point on the line. The question is this: if you look at this line here, what would happen if you try and work out the gradient at 0, 0? I mean, looking at this here, what would happen what would this formula give you here? If this formula gives you the gradient at any given point on this line here, what happens if you try and work out the gradient at 0, 0? I mean, will it work out this gradient here? Will it work out this gradient here? Or will it work out this gradient here? Or will it work out this gradient here, if this makes sense at all? This one here. Or will it work out this gradient here, if this makes sense? What's a gradient here? Like that, so what would happen if you try to work out the gradient at 0, 0 here? So I don't know. Well, I don't know. Yeah. Okay.